the same time as the individual projects becoming more complex and our concerns about their ability to deliver them becoming apparent, they were also clustering a lot of those projects around a relatively short period of time. They'd been in existence 6 years, they'd delivered 6 projects, and yet they had another 14 or so in the pipeline. These 14 were all being delivered in a 2-year period at a time when they were also trying to develop an offshore wind farm, which was in excess of 10 times larger than anything they'd done before, was using much larger turbines, and was presenting additional difficulties in relation to going into an offshore environment where very few of the people concerned had any marine experience. Energy yield. This provides, I think, a good example of one of the other principal issues that we find when we're looking at these opportunities, is that very often you get overestimation of the revenues. If you look at onshore or offshore wind projects, one of the principal characteristics or principal sources where things can go horribly wrong is estimating how much energy you'll get out. One of the projects that we've entitled Project Bruggen was declaring a full year estimate in terms of megawatt hours of 24,000 megawatt hours. Now, the revenue associated with any of these projects is directly proportional to the energy output. When we looked at what we thought was likely to come out of this, again, you're looking at something which is potentially 12% lower than was what was being declared in the first instance. If you multiply this across 20 projects, then suddenly you start to have major concerns about the ability to deliver the kinds of revenues that they're talking about. And certainly the kinds of revenue over forecast issues that we were seeing were a systematic fault rather than something which was very much a one-off. Management issues, as I've said, they had a strong management, but their team was relatively small. There was various areas in terms of their ability to identify what they could and couldn't do in-house. As they'd grown in confidence, they were very unwilling to let go in all kinds of areas, both technical and also project management. And we were able to use a fairly standard innovation model to actually identify which aspects of the innovation chain they were strong in and those which they were much less capable of accepting themselves. This provides an example of where their project management was leading them to make decisions which we felt weren't as strong as they could have been. If you take a conventional wind project, one of the first things you do is that you actually do the energy yield analysis. The energy yield analysis not only gives you the outlay of the turbines themselves, but also allows you to determine whether the site's attractive or not, but also whether you want a particular turbine. Turbines tend to be optimised for different types of sites. So, for instance, some sites with relatively low wind speeds may favour one particular turbine over others where wind speeds are somewhat higher. The way that they were approaching projects, because the lead time for delivery of wind turbines is actually quite long, they were buying their turbines before they did the energy yield. They were signing their leases or acquiring the sites before they did the energy yield. And the energy yield work was only being done once they got to project financing. They were financing these projects on a non-recourse basis, where the providers of the recourse financing required a energy yield as part of the due diligence process. When we probed them on this and asked the question, well, why do you do it in this order? Why do you schedule it in this way? The argument went, well, Belgium's actually a fairly flat country. My aunt tells me her hat blew off 2 times last week. She says it's very, very windy. And they weren't taking it anywhere near as seriously as we would expect if we were looking at the several £100 million financing that was proposed for this. Fuel availability. I'm using this as an opportunity to demonstrate the importance of actually getting input in relation to certain commercial aspects. One of the most difficult things with biofuel projects is not so much the technology itself. A lot of the technologies you use for utilising biofuels, whether it's tallow or any other sort of bio waste, is that the the fuel supply issues almost always are the most important factor. And I think this demonstrates that there are certain things that you can only learn by doing, or that you can get from other people. One of the points I come back to later is that enthusiasm isn't necessarily a substitute for experience. And when you look at those factors on the right hand side, being able to work your way through these issues as someone who's new to project financed or venture capital finance projects is something that you can only do if you're bringing in people who've been through this process before. You can't start with a blank sheet of paper, do a risk assessment, and expect to come up with contracts for fuel supplies or equipment supplies or offtakes of electricity unless you've got people who've done this before. Other recurring themes in low carbon. This isn't something which necessarily occurred in this particular project, but lack of systems and processes. We go to talk to companies all the time with interesting concept designs, and we sit down and they tell us about a particular technology. The example I normally give is that we were talking to a company recently about a tidal stream technology, and they were telling us about how great the blade pitching mechanism was for the technology. And this is the way by which you feather the blades to change the angle of attack to cope with different wind speeds or tidal speeds in the case of a tidal stream. And they kept telling us how this gives us a 3 or 4% increase in efficiency. And when I asked the question, yeah, but what does it do to reliability because it's independently variable pitch? They said, but it gives us a 3 to 4% increase in efficiency. And what they didn't seem to appreciate was that in order to benefit from those efficiency gains, the damn thing has to work. If the reliability is poor, you're not going to actually see those sorts of benefits. And one of the things that we constantly see is that if the people pitching to us come from an aerodynamics background or a thermodynamics background or reliability background, that's exactly the sort of focus that they put on their arguments. You know, if the only tool in the box is a hammer, the whole world looks like a nail. And one of the things that we want to see is we want to see people coming to us looking at these sorts of things in a more rounded way. And the only way to do that is actually to have systems and processes, checklists that say you will not proceed beyond this stage unless you've looked at these issues. And the kinds of issues that we would look at when we're developing technologies, and we apply the same sorts of systems to low carbon technologies as we would an aero engine or a ship propulsion system or an industrial gas turbine, is can we make it, can we deploy it, can we maintain it? The other example I give is that we saw a nacelle on a tidal stream device, and I asked the question how they'd come up with the dimensions on this nacelle, and they said, oh, it's all related to buoyancy. But if you increase the dimensions on that nacelle by only 18 inches, you could actually get someone inside there to do maintenance on it, and it wasn't a case of literally cutting it open in order to get access to those components if something went wrong. These are the kinds of things which in small companies, because they're working so quickly and they're so focused on the interesting concepts that they have, that they're not able to necessarily apply this holistic view. And very often the first people who are those who are being pitched to in a situation where venture capital is required, or growth capital, or a hedge fund is looking to acquire the company. And this, I think, is probably one of the key things that a company like Royce or another systems integrator can bring to these kinds of opportunities.